Student, this is video number 2 in the hypothetical testing, and we will work now and complete what we started. And just I share the screen just to go for my notes and show. So we are done now for the first part, which is how I will formulate the hypothetical null and hypothetical one. Again, I would say hypothetical null is simply the mu will equals the population, the number of the population in the example. So he said the US had a mean U body of weight of 77 kilograms. Standard deviation was 19. This is all for the population. We didn't talk about any sample. So when I come to formulate H0, I would say the mu, which is the average of the population. Mu, the average of the population was 77. And usually I give it equal. Okay. The hypothesis one or the alternates depends on what he said in the example. But he said here the population now differs, means is unequal. For that reason, we will use unequal, which is the sign like this. So if he said greater than, it will be this way. It's unequal, it will be that way. And we said after this, we'll do the procedure. The first thing is formulating hypothesis 1 and hypothesis 0. Then we will go for, after this, the second step is find the critical value, which we'll find from the tabulations like I will show now. Third, compute the test value. What test we will use, because I said there are a lot of tests, about 15 to 20 tests, parametrics and non-parametrics. Then make the decision to reject or accept the hypothetical null. Then summarize your results, like you will say the decision or your report. What did you see about this? Is really the average increased than 77 in nowadays, or is less than 77, or it is equal still the same like the researcher did before, it's 77. We will see the claim of the guy who said that the average is 77 kilograms for the Americans. If this claim is right or wrong, or what he said might be right, more or less. That's what we come to investigate. It's like the jury, like what you said example. Here also I wrote for you in details. It's written in details how we'll do an. Okay, let's go now to see some examples of formulating H0 and H1 so that you will be familiar with how to formulate H0 and H1. And I will go on them example by example. I will go on them example by example. Let us see this example. We have a medicine that is being manufactured, and each pill is supposed to have 14 milligrams of the active ingredient. Look what he did here. H0. The mu will equal the average on the population, because I didn't do any test yet. I didn't take samples. I didn't do anything. I'm working on the population here. For that reason, you have 18. You are talking about the population. Again, I'm talking about the population. So H0 or mu will be the average of the population. The average of population, which is 14. Okay. One, HA or H1. HA means the alternate, or H1. Some books say HA. Some books say H1. So it doesn't make a sense. It makes no difference. You can say H0, H1, sorry, H1 or HA. It does not equal because of what? Because of what? What are, you see, because we are checking if it is different now or no. Different means I will put equal. If, okay, the medicine is being manufactured and it's supposed to have 14, what are our null and alternative sets? So here, because is it different or no? Then I will put in equal. Mu will equal the 14. Okay. Also, you have another examples here. I put for you some examples. Here is the tails and one tail test and two tail test, and declared here so much. So this one, when we say based on what we'll have on the alternates, on the alternate hypothesis, we will check if it is unequal, then it's a two parts. If it is mu is greater than, okay, then this case h1 mu is greater than mu 0, then in that case greater will check this the right part, less will check the left part. So I will just summarize it up, sum it up again here on the board. I will sum it up on the board here in front of you guys. Okay. When we come to check, we will check based on the what we have. So for two tails test, the two tails test, this is the two tails test. This is when I say h1 mu or mu doesn't equal. Okay, when we say mu doesn't equal, then I would use this kind of test. This is two tails test, two tail. If it is h1 is greater than mu is greater than, like that one, when h1 is greater than, in greater than we make it right on the right side here. Right tail test. This is right tail test. Right tail test. And if it is in the left, when we say h1 mu is less than, in that case it will be left tail test, like this way. Left tail test. And again, I'm just reminding you back that this or this or this depends on the context in the example, on what he's saying in the example. If he said greater than, then we'll use this and it will be a right tail test. If he said less than, then we'll use this formula and it will be a left tail test. This is the main points regarding the tests here, and I will go back to share the screen right away because I need to share this screen. The T tabulated and Z and alpha is the degree of confidence, which I will give you in the example, and this is why where we will look in the tables, which table we will look in. This is very important point before we go to a solution of examples. Usually, we have alpha, which means the error. Let me also explain it to you here. If alpha is the mistake or the error, then the confidence is 1 minus alpha. So what this mean? What does this mean? Easily, and you will come by, when you do practice too much examples, you will even memorize the numbers of the tables, because in social studies here we have only a degree of confidence 99% and the degree of confidence 95%. So I will show you what is the meaning of alpha and what is the meaning of C, or the degree of confidence, and what do we mean by them? What do we mean by both of them? Let me stop sharing so that I will have the board here, because usually in this kind of classes it's very important to demonstrate it on the board, because it's just when you signal with the prompter is not enough for the students to get aware and understand what we are talking about here. Or some might be like hesitated in understanding or whatever. So it's better for me to do it on the board and show it clearly. Let me show you what is the meaning of alpha and the C, and how does it differ or make sense. Okay, let me say that in social sciences, like business, like our studies in business, we usually use degree of confidence, the following degree of confidence. When C is 99%, then alpha will equals 1 minus C will equals 1 minus 99% will equals 1%. Okay? This, what do we mean by confidence and what do we mean by alpha? What do we mean by the confidence and what do we mean by the alpha? The confidence is, let me tell you something. That confidence means I'm sure of my results with 99%, I'm sure of my results. And I'm not sure for only 1%. Let's say about the COVID now. When you hear about the COVID, that the degree of confidence of the COVID vaccination is 99%, means they are sure 99% of the results of the vaccination, and the vaccination will be good for the people. And they are not sure with the rest, which is the alpha, with about 1%, they are not sure of the. If I tell you as example, see, today I'm going to pass by you to study with you today is 99%, means that I'm not sure I'm coming with only 1%. If I tell you I'm coming to see you today, 99%, I'm sure 99%, then I'm not sure for 1%. Then the C, or the confidence, is the percentage, and alpha is 1 minus C, because you know all the probabilities are equals 100%. So it will be 1 minus C, 1 minus 99%, that will be 1%. We have said in social sciences, we have 2 degrees of confidence. The first degree of confidence is 99% in all social sciences, except especially particularly business. The second degree of confidence is 95%. And the 99%, when I use it now, then alpha will equal 1 minus 95%, then alpha will equals 5%. Okay, same example like we said before, but now I will say, make a sense. If I say I will pass by you 95%, I will pass by you 95%, that means I will not be able to see you today is 5%. I'm confident, I'm sure I will pass by you by 95%, but I'm not sure, the alpha, I'm not sure. What about 1 minus the 95? 5%, I'm not sure that I will come to see you today. 95%, I'm sure that the vaccination of the COVID will give a positive results to the people and will cure and treat them, or will prevent them from getting COVID. 5%, I'm not sure if this vaccination will work or not. This is the meaning of the degree of confidence. And we also will check in the schedules about how to use the degree of confidence. And anyhow, those numbers are the numbers like I told you before. 5%, 1%, 5%, 1%, but it differs on one tail or 2 tails. So you will come by too much your experience in solving. You will know when it is 19.96 and when it is 2.58 and when it is 1.6. This is the outputs. This is the numbers which you will compare. This is the Z tabulated, which you will get from the tabulation. Okay. As example, when you go for one tail tests under 1%, alpha 1%, okay, for the confidence 99%, one tail test, it will give you 2.33. In the table you will find this number, 2.33. okay, when you go for tail for 5%, alpha 5%, and one tail, then 1.6. By the way, the one tail right and one tail left are the same numbers. Look at this, 1.64, 1.64, 2.63, 33, 2.33. So left or right, it gives you the same numbers, okay? Left or right. But the 2 tails test, we have 5%. If it is 5%, it will be 1.96. If it is, you are discovering with alpha 1%, it will be 2.58. Those are the hypothetical testing in very easier way. Okay, here we go. Let us see first example now today in our work. Let us see our first example.